Hi, I'm Kwan, a final year civil engineering student from Curtin University. I wanted to work for a transportation consulting company because after observing transport networks from other countries, I came to the realization that transportation in Perth is far from perfect. So I applied for ARRB because I'd like to take part in the process of working on more sustainable approaches to transportation. I work with the Safe Systems team in Perth, and I've worked on all sorts of projects varying from mining and heavy vehicles, network operation, and parking. A particular project that I've worked on required me to go on site to survey and model 2 intersections. Those intersections were expected to have an increase in traffic due to the development of a primary school, and the modeling was done using a program called Sidro. This may all sound tedious, but it really wasn't. For the modeling parts, most of the settings were left at default. I simply entered the volume of traffic into the program and only looked at the degree of saturation and the level of service. This project was rewarding because I wrote a sectional report and was named the co-author. My internship has been pretty good. I had the opportunity to meet clients, attend meetings, and do all sorts of engineering related work. Everything was well structured until the departure of my supervisor, who frequently assigned me work. Things got a bit slow afterwards, but luckily this intern project kept me busy. Overall, the program has been helpful. I had the opportunity to learn how the industry works. The only suggestion would be to have proper rotation for the interns. The NASRA roughness meter was first introduced in 1972 by the National Association of Australian State Road Authorities. The roughness meter was mounted on the differential of the vehicle to provide measurements of the road roughness, which reflects the ride quality perceived by the average commuter. The NASRA roughness meter is a response-based mechanism that sums up the movement of the rear axle in one direction with respect to the body. This schematic diagram illustrates a longitudinal view of a road with a bump on the road. Here we have a survey vehicle with a roughness meter. As the vehicle approaches the bump, the roughness meter reacts and displays it on a roughness counter. And this is how it works. Here we have a diagram of the roughness meter from different angles. When the survey vehicle hits the bump on the road, the differential will move up and will cause an upwards movement to this cable. It is better to observe this from a cross-sectional view. So again, this is a cable that is attached to a chain which will rotate the clutches when the differential moves upwards. The rotation of the clutches are then displayed through a roughness counter that is located at the front so that an operator can record the data. Anyway, I really enjoyed my time at ARRB, and thanks for listening.